is what? What is 2 over x cubed? 2x to the negative 3, exactly. This is that. It's the same thing. What is the derivative of 2 to the x? We did this a bunch of times. What is the derivative of 2 to the x? Yeah, ln 2 times 2 to the x, right there. What's the derivative of 2x to the negative 3? You drop the negative 3 to the front. Derivative of 2x to the negative 3. What's the derivative of 2x to the negative 3, everybody? Yeah. Yeah, there you go. Fantastic. And then this is the same as that. That's the same right there. So now you're done. That's it. That's all you do. Do you have to use the product rule here? No. Why don't you use the product rule? There ain't no product there. You don't use the product rule because there is no product. That's simple as that. Generally speaking, though, one thing for notation purposes, I don't really like it written ln 2 times 2 to the x. What do I like? I like 2 to the x times ln 2. Why? It makes it clear that these are not, the 2 and the 2 to the x are not being grouped together. You're not taking the natural log of 2 to the x. You're not taking the natural log of 2 to the x. I like it that way. So this is fine like this. You could write it like that. Voila. A pony times e to the x. What's f prime of x? What's f prime of x? It's literally the same thing we just did. What? It's e to the x times pony. Nothing changes. We just did it over here. Over here, what did we just see? Does it matter what this number is? ln 4. It's along for the ride. So what's the derivative of pony e to the x? It's the same thing. Doesn't matter what it is. The constant is just along for the ride. The constant is just along for the ride. That's it. Like if you have a function equals a constant times another function, like this, what's f prime of x? The constant times what? G prime of x. But in this case, what is the derivative of e to the x? E to the x. It's just, it stays the same. So the derivative of anything times e to the x is the same. This right here is just a number. A number. That's it. So what do you end up with? ln 3 times ln 3 to the t. That's it. That's all it is. That's all it is. So going back over here and generalizing it just like we did before, if we go over here, let's say I said f of x is equal to pony to the x. Can someone tell me what the derivative of this is? What's the derivative of that? Pony to the x power. What is it? ln of pony times pony to the x. That's correct. That's all it is. It doesn't matter what the number is. What? No, there's no product rule. I'm saying pony is just a number. This is a number. There's nothing being multiplied together right there. There's nothing being multiplied together. There's no multiplication in the original function. Pony is just a number. That's all I'm saying it is. We're just using the rule right there that I had in red right here. We're using this rule right here, the derivative of exponential functions. There's no products in this section of the homework. There's no product in this section of this homework right here. There's later, but not right here. Square root of x. Low. What's the derivative of the top? What's the derivative of the top? You should be able to just know what the derivative of the top is. 2x minus high d low. So you have to do the derivative. What's the derivative? So the square root of x, everybody, is x to what power? Is x to the 1/2 power. So what's the derivative of this if you want to do the derivative of that? So if f of x is equal to x to the 1/2, what's f prime of x? What do you drop to the front? 1/2. So it's 1/2 x to the what power? Negative 1/2. Where'd you get the negative 1/2 from? Where'd you get the negative 1/2 from? 1/2 minus 1. Exactly. So what goes right here? What goes right there? What goes right there? Yes, 1/2 x to the negative 1/2 all over what? All over what? The square root of x squared. Yep. Now, can you spend some time simplifying this? No. Yes, you can. There's some simplification you can do, but that's what I want to see. That's what's important right now. That's what's important right now. That is the derivative of the function we just did. I'm not asking you to spend hours and hours and hours simplifying things right now. That's not what's important. So over here, let's take a look. There's some simplification here. So can you simplify it a little bit? Absolutely. Does it simplify to this? Sure. The big thing you need to understand right now, the big thing is how to get the derivative. This is the important thing to get right here, the derivative. Yes, all of this right here is important, but this is the simplification. Know how to do the derivative now. That's what's important. Know this part. Yay, exciting. What's g prime of x, Jen? What's the derivative of g? 2x. That's going to get annoying, but I'll live with it. 2x. And what's h prime of x going to be? Correct. Exactly. So if this is equal to g of x times h of x, you know you do the derivative of one times the other. You do all the pairs. What are the two pairs here? There's the pair and there's the pair. So you do the derivative of the first. So you can say, so f prime of x is going to equal 2x times what? 2x times what? So it's this pair I'm looking at right here. So 2x times x cubed plus 5 plus the first x squared times what? Yeah, so you got to memorize it. You have to memorize it. It's the derivative of each one times the other one. It's the derivative of each one times the other one. That's it. Now, can you simplify that? Sure, but that's not what I'm asking you to do right now, okay? So that's the first way. That's the first way we could do it. We could use the product rule. Is there a way to make it so we don't have to use the product rule? What could we do to this first before we do any calculus? What could we do first? Yeah, so when you say simplify, one word, what are you going to do? Multiply. Distribute, right? So what does that become? What is f of x actually equal to? X to the fifth plus 5x what? Kids. Saturday. Let's just fake it out. 5x squared. There we go. Nice. So can we do the derivative here? Yeah, what's the derivative going to be? What's the derivative of that going to be? Do we need the product rule anymore? No, we did. There we go. There's the pep. There's the pep. What's the derivative now?
5x to the 4th.
Plus?
10x. Yeah.
There we go. So here's the thing. If we did this two ways, should we theoretically get the same thing?
Yeah.
We should. Now, is there any way to simplify what's in the blue? No. But can we simplify what's in the red? Yeah, so let's see if they are the same. Let's distribute here. What do you end up with? 2x to the 4th. It keeps jumping. I don't know why it does that. 2x to the 4th plus 10x, right? And what's this one when we multiply it? Plus what? 3x to the what? 3x to the what, everybody? 4. Hey, do we have like terms here? We have this term and we have this term. We combine them. What do we end up with? 5x to the 4th plus 10x. Is that the same thing?
Yeah.
It is the same thing.
Look at that.
It is the same thing. So sometimes if you multiply first, it's a little bit easier. Sometimes if you multiply first. So simplify first if you can. Are you always able to simplify first? No. So for example, like 3 to the x times 4 to the, I don't know, 4 to the x. Can you simplify that? No. No, you can't simplify that. Well, you can simplify it a little bit, but not the way I want. So like 3 to the x times x squared. Can you simplify that at all? Is there anything you can do to simplify that? No. So if I asked you to differentiate that, what rule would you have to use on that one? What rule would you have to use on this one? The product rule. You'd have to use the product rule. Exactly. Product rule. Okay. You guys have done a bunch of this work, and you can help me out. Have we done it before where we found where a function is increasing and decreasing? Yes. Have we before found where a function is concave up and concave down? Yes, we have. So ready? So we're going to do it now. So h of x. So what did you find out h prime was? It was e to the x times 2x plus e to the x times x squared. So what did you factor out of both of those? That's the first derivative. Do you agree that that's the first derivative?
Yeah.
Yes, that is the first derivative. The first derivative can tell us where it's increasing and decreasing. Where the first derivative is positive, it's increasing. Where the first derivative is negative, it's decreasing. So in order to find those regions, we first need to find out where the first derivative is equal to 0 or undefined. So how do we set, what do we do to find out where it's equal to 0? We set it equal to 0. So we have this thing right here. We have e to the x times 2x plus e to the x times x squared is equal to 0. What can we factor out of both of the left? So we have e to the x times 2x plus x squared is equal to 0. Here's the key realization. This might seem like it's totally crazy hard to do, and it's so weird. E to the x, that is always what? It's always what? Always greater than 0. Is there any way to make e to the x negative? No, there's no way to make e to the x negative. E to the x is always greater than 0. So what's the only thing here that can be equal to 0? That. So, yeah. So, well, you can also, another way you could, quote, get rid of it, you can divide both sides by e to the x, and that you can do that because e to the x can never be 0. E to the x is always positive. So what do we solve? 2x plus x squared is equal to what? What can we factor out of that? So it's x times 2 plus x is equal to 0. So x is equal to 0 or what? Or, careful. So then you have a number line. You have a number line, and remember we did this a bunch, -2 and 0, and we tested the second derivative. This is the x value, and this is, sorry, the first derivative. We know there's 0 in this case, so it's either positive or negative everywhere else. What number is between -2 and 0? What number is between -1? Where do we plug that in? We plug that into this right here, because e to the x is always what? Positive. Plug in -1. What's 2 times -1? -2. -2 plus 1 is -1. So it's negative in between. What's to the right of 0? What's to the right of 0? Plug in 1. Plug in 1 into the circled green. You get 2 plus 1 is positive. Plug in -1. What do you get? Oh, I'm sorry. -3. Sorry. -3. Excuse me. Plug in -3. What do you get? You get positive. So where is it increasing? Where is it increasing? Negative infinity all the way to? Union what? Yes, that's where it's increasing. Where is it decreasing? -2 to 0. Do I use hard brackets or soft brackets? Soft. You do soft brackets because what's happening at -2 and 0? It's not increasing or decreasing. This analysis that we just did, we're doing it the exact same thing for the next part, but it tells us about concavity. We haven't figured out the second derivative yet, but we're going to do the exact same analysis. We're going to take a derivative, set it equal to 0. When you're confused on a question, everybody, in calculus, the most common thing you ever do in calculus is take a derivative and set it equal to 0. That's super common. Yes?
Why is it just
Concavity. So if we talk about concavity, we have our first derivative right there, the first top line right there. Concavity, we need, what derivative do we need? We need the second derivative. So here's the thing. If this right here, everybody, if this right here is the first derivative, what do we need to do to this now? We need to take the what? If this is the first derivative, we need to take the what of this? We need to take the derivative of this. So how many times do we need to use the product rule? Twice. We need to use the product rule twice, because you need to use the product rule here and you need to use it there. It looks like it's going to be really nasty, but what's the coolest thing about that function that makes it really nice? What's the nicest element? What piece of that function makes it really nice? E to the x is awesome, because what's the derivative of e to the x? E to the x. So let's do this very, very carefully. Let's do this section first. It's the derivative of the first, so it's e to the x times the second, plus the first times the derivative of the second. That's that derivative right there. Take a look and see if we end up with the derivative of, what do we end up with the derivative of? The derivative of the first, so e to the x times the second, plus the first, what's the derivative of the second now? 2x. Take a look at this and tell me if you agree with it. Do you agree with that derivative right there? We said, yes.
Why are you taking itself and then taking the derivative of itself and then adding to it? I thought you were taking the derivative of the next one.
E to the x, like this. Nick, what? So we end up with 0 is equal to e to the x times what? 2x plus 2 plus
2x.
Yeah, and again, e to the x is always what? What is that?
Always greater than 0.
It's always greater than 0, right? It's always greater than 0. So the only way to make it equal to 0 is to have 2x plus 2 plus x squared plus 2x equal to what?
0.
0. That's the only way to make it 0. Yes, Leona.
So what I
We should get the same thing. So do we have some like terms? Yep. So what do we have here? X squared plus 4x plus what? Equals 0. 4 squared minus 4. What's the a value? What's the c value? 2. So you end up with 16 minus 8 is what? 8. So you get x is equal to negative b. So what's negative b? Negative 4 plus or minus the square root of 8 all over what? All over what? 2a. So it's all over what? 2. The quadratic formula? X equals negative b plus or minus the square root of, do you remember this? Because, Nick, this, no, it's fine. This right here, is this nicely factorable? Is there any way to what do I draw now? Yeah, a sign chart, yes, exactly. Very good. So let's call that A and let's call that B. So this is where the B and this is A right here. So then you have to test some numbers. You have to test some numbers, you have to test some, from where to where?
From -2.
Nope. Concave up goes from negative infinity all the way to B. Union what?
Oh,
Concave
from
up is,
positive infinity.
yes.
Okay.
Sorry, from what to positive infinity?
From A.
Yes, exactly. And then where is it concave down? From?
Soft bracket
Ye-
B to A.
Correct, exactly. That's it. Yes. What do you set that now equal to? 0. So 0 is equal to 3 to the x times 3x squared plus 3 to the x times ln 3x cubed equals what? Oh, equals 0. You need to solve that for when it's equal to 0. So what can you factor out of both? What can you factor out of both? Factor out 3 to the x. So 3 to the x times what is left inside? 3x squared plus what? ln of what? 3? ln of 3 times what? Let me just get this right. Did I write this? Okay. Are you with me so far? Are you okay so far?
First step, why do you put x to the x cubed?
Now, what do you know about 3 to the x? What does that always have to be? Not 0. It's always greater than 0. So what's the only way this can be 0? When 0 is equal to 3x squared plus what? ln 3 times x cubed. What can we factor out now? What can we factor out now? What can we factor out on the right side? What's in both of those? X squared is in both. So what do we have now? We end up with, can someone tell me what you end up with? 0 is equal to x squared times what? Times what? 3 plus, yes, 3 plus, sorry, this is jumping. 3 plus x ln 3. Nice. Can someone tell me what one of the answers is? If we want to make that equal to 0, what's one of the nice answers?
0.
So x is equal to 0. Nice. Or what else do we have to solve? 3 plus x ln 3 is equal to what? 0. If you have two things multiplied together, how do you make it 0? Either the first thing is 0 or the second thing is 0. Well, that one's 0. We're done. This one right here, what do we subtract from both sides?
3.
So you have x ln 3 is equal to negative 3. So what does x equal? Negative 3 over ln 3. Did we find our two answers? We did. Yes.